All right, so we got 2013 number 5. This is non-calculator. So part A, I'm just telling you right now, really sucks. Um, so we have an equation f of x. We have an equation g of x. It doesn't tell you on your graph which one is which, so you need to have some kind of sense of graphing. Okay, f is a quadratic with a positive leading coefficient, so it should be opening up. Okay, cosine sounds like coast. Okay, where you start at the top and we're going to coast down. Okay, so you guys should have some indication from that g of x is going to be your top equation in this. F of x is going to be your bottom equation in all of this. It looks like they intersect at 0, 4 and at 4, 2.
No,
Okay,
at 2-0.
is that what I said?
No, you said 4-2.
I said 4, 2. That doesn't make sense. All right, so it looks like they intersect at 4 and at 2. Okay, you could roll the dice and get lucky that they do, or you just quickly double check. Okay, I'm just going to quickly double check for you. So we get f of 0, plug 0 in all this, we should get 4. So that one works out perfectly at 0, 4. We plug in g of 0, plug in g of 0, this is going to be 4 times cosine of 0. Well, cosine of 0 is our x value when we're at 0 radians. Okay, our x value at 0 radians is going to be 1. 4 times 1 is 4. Okay, so they do intersect at the point 0, 4. If we quickly plug in 2, let's see, f of 2 is going to be, okay, 2 squared is 4 times 2 is 8. Minus 6 times 2 is minus 12 plus 4. 8 plus 4 is 12, minus 12 is 0, so that is indeed at 2, 0. We then just figure out, well, g of 2 is going to be 4 cosine of, so this is going to reduce down to pi over 2. Now our x value for cosine at pi over 2 is going to be 0. 4 times 0 is 0. So those are our points of intersection. Okay? Just be careful that you guys end up assuming that. Okay, on your exam, you're going to get to use a calculator, so you won't have to worry about that as much. For part A, we need to figure out the area of R. Alright, so it's really just going to be top minus bottom. If we're doing top minus bottom, it's going to be with respect to x. Okay, so I'm going to integrate from 0 to 2. Alright, top minus bottom is just going to be g of x minus f of x dx. Okay, now if you had a calculator, you would have these in your calculator stored as y1 and y2. You're supposed to do this one without a calculator though. So we're actually going to need to write these all in. So I've got the integral from 0 to 2. G of x is 4 cosine of pi over 4x. Okay, another way that you could do this is split this up, where we then minus the integral from 0 to 2. Okay, I'm going to do that in a minute. So this is going to be minus all of f of x, which is minus 2x squared plus 6x minus 4. Okay, make sure I put my dx on all of this. Okay, I didn't put parentheses here because I already distributed all of my negative to all three of those. Now, when I integrate all this, guys, I'm just going to split this up because this is gross looking. Okay, maybe you need to do some u sub with this. So I've got the integral of 4 cosine of pi over 4x dx. We're going to integrate that from 0 to 2. Okay, and I'm going to integrate all of this next. So I've got plus the integral of negative 2x squared plus 6x minus 4 dx. That should be easy to integrate. Still going from 0 to 2. Okay, let's go deal with this guy. I'm going to bring the 4 out front, which is fine. Okay, but to integrate this, you're probably thinking u sub u is going to equal pi over 4x, means du dx is going to equal pi over 4, which means 4 over pi du is going to equal dx.
If you haven't started catching on to this, if you're only differing by a constant, this is where, if we could have done that before we were on remote learning, if we could have done our integration by parts unit, that's why we do it before we review for the exam on a typical year, you start to notice that. You're like, oh, so it's like chain rule, so the derivative of the inside would be pi over 4, but when we integrate, we use the reciprocal. Like, if you haven't made that connection, maybe now would be a good time to, like, have an aha moment and make that connection.
Just be careful, because I've had years where even when we do integration by parts, students, it's still a 50-50 shot whether they're going to guess which way it goes correctly. Okay, so just be careful, make sure, just make sure you're getting it right. So I've got my 4 out front. Okay, integrating, my boundaries are now going to be in terms of u, so we're going to hold off on that. This is going to be the integral of cosine of u. Dx is now going to be pi over 4 du. 4 over pi. I think that's what I said, 4 over pi. So now we got to figure out, well, 0, plug in 0. U of 0 is going to be 0. 2, so this is going to be 2 pi over 4, which is just pi over 2. Okay, be careful with all that. That's why I split this up. Alright, because I'm doing u sub for this part, not this part. I can leave this all in terms of x. So now we're going to get, this is 16 over pi. Okay, the integral of cosine is going to be sine. Okay, I'm going to leave it in terms of u and just evaluate from 0 to pi over 2. And then let's do all this. So we get plus, actually this is going to be a negative for my first one. So we get x to the third. This is going to be a negative 2 over 3. Add 1 to my exponents, divide by my new exponents. Add 1 to my exponents. Okay, this is going to be evaluated from a 0 to 2. So we're getting close now. This is all on part A, remember? If I were on my test, I might have gotten to some point and been like, all right, I got to move on. Try part B, try part C, and I can come back to it if I have time. Okay, be careful. Don't spend too long on any one part on your test, okay? Because one part is not going to be worth that many points. Okay, it's better to spend time on everything. So I'm going to plug this in. I got 16 over pi. We have sine of pi over 2 minus sine of 0. Okay, the way I have this written is not good. I need that to be distributed to both of these. Okay, so make sure you have your brackets or parentheses or something there. Over here, we're going to get plus, okay, I just got to plug everything in, negative 2 thirds, 2 cubed, plus 3 times 2 squared, minus 4 times 2. And then we would minus by plugging in 0 for all of these, but if you guys recognize, 0 cubed, 0, 0 squared, 0, 4 times 0 is 0, okay? Things to be careful on, if you have e to the x, okay, that's not going to go to 0. Or if you got trig, typically, okay, be careful on that as well. Okay, so this is going to be minus 0. Don't really need to put minus 0. You should evaluate and figure out what sine of pi over 2 is. So this is going to be 16 over pi times sine of pi over 2 is just going to be 1. Sine of 0 is 0. And then we just need to copy all of this garbage down. Okay, guys, remember this is non-calculator. Even if it's, well, if it was a calculator, hopefully you would just math 9 it. Okay, but this is all you really need to do and you're done. Don't keep spending time on this problem. Okay, be done with all that garbage. Okay, that already took way too long, but part B and part C are going to be a lot quicker. Okay?
And I have heard before, I don't know how much I believe it or not believe it. I have heard before that they would even give you full credit even if you didn't do your exact values, and I was like, what? But maybe if you were short on time and you knew it was non-calculator and you wanted to toss the dice, maybe you stop even here. I don't know, like I say that, I believe that. We've always made you guys, even if it's not calculator, at least evaluate your trig because we were testing you on that. So I would have gone to this spot just like Mr. Tony did and then stop. But make sure you don't keep going farther where you have to get a common denominator, blah, blah. What are you doing? Stop. Once it's all numbers.
Alright, so we got part B. Part B is asking, write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 4. Alright, yeah, y equals 4. Alright.
Yep.
So, this is my horizontal line, y equals 4. Okay, so I'm really thinking big R squared, little r squared, we're going to have pi. So, I'm going to bring my pi out front right now. I'm integrating. We're going to have a big R squared minus a little r squared. I'm going to do this with respect to x. Okay, because if I was really, well, I'm rotating vertically here. So if I were to slice these guys up, each one of these little pieces would be dx. Okay, that's only when you rotate horizontally that you're going to have with respect to y. So we really just need to figure out what is big R and what is little r, because my boundaries, as we already know, is going to be from 0 to 2. So we need to set up, but not actually evaluate. Okay. So once we figure out what big R and little r is, and then we're all done. So let's check out big R. Okay, so this is going to be my big R, guys. It's always changing. Okay? Understand that the function represents the distance from your axis to your curve. So what we really want is this. Okay? It's really just going to be top minus bottom. If you guys get that in your head, you're going to be fine. My top equation is 4. My bottom equation here is f of x. So big R is going to be 4 minus f of x. So here we got pi. We're integrating from 0 to 2. Okay, I've got 4 minus f of x. I'm going to square that. Minus my little r. Okay, little r is going to be this other one. Alright, so it's really going to be, like I said, top minus bottom. If you guys think about this, g of x is representing this distance right here. Okay, we want this distance, okay, which is really going to be 4 minus that curve. Okay, once again, it's just top minus bottom. So this is going to be 4 minus g of x. It's all going to be squared with respect to x, and stop. Okay, you're all done. It's already, g and f are already defined, all right? You don't have to go through and actually write out what f and g are. Just leave it as 4 minus f squared minus 4 minus g squared. Have your pi out front. We're all good. Let's do part C in red. I don't know why. All right, so part C, the region R is the base of a solid. For the solid, each cross section perpendicular to the x-axis is a square. Write but do not evaluate an integral for that solid. All right, so guys, the easiest one they could ever give you. Okay, is perpendicular to the x-axis. So I'm telling you, like every problem I've ever seen on the AP exams is always perpendicular to the x-axis. I don't think I've even seen one that's perpendicular to the y-axis.
Yeah, not with known cross sections. It does always seem like it's with the x-axis.
Okay. Our cross sections are going to be a square, so it's just really going to be your base squared. So I always like to go ahead and write base squared. This is with respect to x. My base is really going to be top minus bottom here. Okay, g of x minus f of x. So when I go ahead and write this, I've got the integral from 0 to 2. This is going to be, I said my top was g of x minus my bottom f of x. Okay, make sure I square all of this. Dx, and we're done. It says write, but do not evaluate. Okay?
That has nothing to do with the pi. Area of a square has nothing to do with pi.
Yeah, don't get always in the habit of always putting pies there. It's silly. All right, for points. Part A is going to be worth 4 points because that took up a lot of my life. All right, so we got 1 point for the integrand. Okay, meaning you knew to integrate this. Okay, that's going to be 1 point right there. Well, really, you could have just gotten a G minus F. Okay, either one, that's going to get you your points. The second part is going to be integrand. Yeah. All right. So the second part is going to be: did you integrate correctly? So where is my integral? So it's going to be like here. Okay, it's really gross. I'm sure you could get 1 point if you have like a minor mistake, but if you totally screw this up, then it's definitely going to be 0. And then you get 1 point for your answer. Okay, so 1 point for your knowing how to integrate that, your integral, integrand. 2 points for your actually integrating correctly, so antiderivative. And then 1 point for actually just plugging in your values and then being done. Part B is going to be worth 3 points. You get 2 points for having this part correct. Okay, knowing you had to have 4 minus f all squared, minus 4 minus g all squared, and you're going to get 1 point for having the correct boundaries in pi. Okay, so 2 points for this, 1 point for that. Part C is going to be
2.
2 points, yes. I don't know why I was. So my paper says it's 2 points. You can get 1 point.
For the integrand.
Yep, 1 point for your integrand, and 1 point for having your correct boundaries and not having pi out there. Okay, if you got pi or some other nonsense, you'd lose that point. Want to add anything? Cool. We're all done.